Hey, so welcome back, and this is another daily code problem. So today it's called maximum twin sum of a linked list, and it's a medium level linked list question. This is actually the third day in a row that it happened to be a medium level question here. That's a linked list one. So yeah, let's get to it. So basically, all that you want to do is you're going to have two pointers, one starting on the left side and one starting at the rightmost node or the tail node here. And you want to calculate their sum. So 5 plus 1 is 6. And then basically you want to move these pointers inwards. So this one now points at 2 here, and this leftmost one now points at 4. And then you calculate their sum, which is also 6. And then because you can't move them inwards anymore, like this is the last pair, you just take the maximum of these sums here, which is therefore 6 because they're both 6, and you output it. And then for the next one, basically same thing here. 4 plus 3, you're pointing at them. Their sum is 7. And then you move it inwards. They point to two 2s. Their sum is 4. And then when you move them inwards, well, there's no more pair nodes here. And so you stop there. You take the maximum, which is 7. And that's how you get that output. Now the trick here, or the problem here that we're trying to solve is that you can't actually move them inwards because this is a singly linked list. There's only one direction. And so you can't actually move 1 to then go to 2. Okay, like you can move 5 to 4 and bring that pointer inwards, but you can't actually move this like 1 and then to 2 pointer. And so that's the issue. So one way you can kind of get around this is there's one solution, which was actually the first submission that I made. And it's this one here, where basically I used a hash map where the key for it was the index. So like 1, node 2, it starts at node 0 and node 4. And then their values was actually like the value of that particular node. And the reason why this is helpful is when you see something like this, is then we would then store, and I'll write that out again, is index 0 has the value 5, index 1 has the value 4, index 2 has the value 2, and index 3 has the value 1. Is then basically you just iterate through the first half of these keys, so up to 1 here, so the first half, and you just kind of grab the first node so that you're on. So if I is equal to 0, and you use a for loop for I in the range of the keys divided by 2, or the length of the array divided by 2, or the length of the linked list, I mean. And you just say, okay, grab me the value of the current index, which is 5, plus the value at the current index, and you just take the length here of the array minus I minus 1, and that will basically give you the one that is at the opposite side of the pointer. And so that will give you 4 minus 0 minus 1 in this case, which is index 3. And so then you can do 5 plus 1, which is these two pointers. So then when you increment to I equals 1, then you can do, okay, grab me 4 here, and then also grab, well, the length is 4 minus 1, which is 2. So then you can do 4 plus 2. Okay, so if you want to pause the video, that's kind of this solution here, which probably isn't good enough to pass an interview, but it'll get you through a competitive programming challenge. So yeah, that's basically just iterate through the map or the linked list, populate that hash map, and then grab their 2-pointer values. But we can do better than this, and we use a popular technique where you reverse the second half of the linked list. And what that is basically it allows you to actually kind of do that algorithm that I was showing you, where you move the pointers inwards. And so the first step is finding the midpoint. And you do that by having 2 pointers, one that moves 2 steps each iteration, one that moves 1 step. I'll show you that in a second. But basically that technique allows you to find the midpoint of this linked list. And then the second trick will be we want to reverse the pointers on this second half of the list so that instead of 2 pointing to 1, 1 will then point to 2. And instead of 1 pointing to like nothing here, none, and being the tail, 2 will actually point to nothing and it'll become the new tail, while the 1 becomes the new like pointer or like the new head of the linked list. Okay, and so that way you can actually kind of have a pointer starting at 1 and move it inwards for the second half of the list. Okay, so if that doesn't make sense, I'll show you the algorithm. We'll implement it together and hopefully that'll help clarify a few things. So first thing is we want to find the midpoint, find the midpoint. And this is kind of like technique 1 or trick 1. And so you do this by having a fast pointer as well as a slow pointer. And they're both going to, or the slow pointer will start at the head. The fast pointer will start at the node following the head. And then you just say, okay, let's keep doing this while we have our pointer and the next pointer. And so the main thing to understand here is that the slow pointer is going to move just 1 each iteration, while the fast pointer is going to move 2 nodes each iteration. Okay, and so basically this will find you the midpoint. And that's because, well, if one person's going twice the speed, when the person that's going twice the speed, this is the fast pointer, hits the end, since they're going twice the speed, wherever the slow pointer is going to be the midpoint. And in this case, we're going to grab the node following the midpoint, because really this is the half, and we're going to grab this node. So then when you have a actually non-even list, the midpointer is going to be this node, and so we're going to get that one there. Okay, so from here, what we're going to do is now that we have our midpoint at that slow pointer, we're going to want to reverse the linked list, reverse the list. And so this is kind of like our trick 2 here, or technique 2. And so to do this, basically, we'll have that new start here. So the node that we're looking at, or we'll just call it current, is then going to be equal to the node following the midpoint, because we don't want to really have the midpoint, we want to have the second half. So the midpoint would really be the end of the first half. So slow.next. And so then we just want to say, okay, while we have a node here, let's swap the ordering. But we also want to keep track of the previous node that we just visited. And so we're going to initially set it to none. And that's because, well, we're starting at 2 here, and we want to reverse all of their pointers. So 2, like we talked about before, we're going to want to point to nothing. And so its previous will be nothing. Okay, and so with each iteration, we're going to say, okay, let's grab the, and we just have to store in a temporary variable here, whatever is following the current pointer. So that's just current.next. We want to do this because we're about to update the pointer of the current node, what it's pointing to, and we don't want to erase that point. So it's going to be equal to the previous. And then what we're going to do is just say, okay, and then the current is going to be equal to the current next. But before that, we'll just want to set the previous equal to the current. So once we move these pointers, all that we have to do is say, okay, now the new previous is what we just evaluated, and the new current is going to be the next thing that we want to evaluate next. And that's it. We will reverse the second half of the list. And so reverse the second half of the list. And then finally, all that we're going to want to do is move these 2 pointers inward. So we're going to have the left pointer pointing to the head, and then we're going to have the right pointer pointing to the previous. And we're saying previous because at the very end of this, I switched my keyboard setting to be Colmac instead of QWERTY. There we go. And so then we're going to set the right pointer equal to the previous. That's because this current will eventually go out of bounds, so we want the new head of the list here. So this is just move pointers inwards. And so we just say, okay, while we have our right pointer, let's just move them inward. So the new right will become the next here. And then same thing with the left pointer. We're just moving them one step at a time. And with each iteration, we're going to want to calculate the new maximum, which initially starts at 0, say in response as this variable. And you just say, okay, the new result is equal to the maximum of whatever the current maximum is, and the left value plus the right value, which makes sense. It's the sum of these values. And we want the maximum. Oh, reference before assignment, right, we want the head.next. Looks good. And submitted. So that's today's daily LeetCode problem. So once again, this runs in O of n time complexity, and it runs in O of 1 space complexity. And that's because we're just modifying the input list. Sometimes they don't want you doing that, but you just want to clarify with them if you're allowed. Otherwise, you'll either have to clone the list or use the first technique that I showed you, which is using a hash map. Okay, so yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.